Okay, welcome everybody to AER Live. This is a series of online interactive workshops from the Applied Ecology Resources. My name's Dr. Vicky Bolt. I'm a Knowledge Exchange Fellow at the University of Reading, and I'm delighted to welcome you all today. Glad that you could join us for this much awaited workshop. Our monthly AER Spotlight series is back, and this month we spotlight a report by Natural England. This report maps the distribution and condition of valuable natural assets across England, including where they can be found and the ecosystem services they provide. All this information is publicly available on AER for researchers and practitioners to use, and was shared through an AER Platinum membership by the UK Government Department for Environment, Food and Rural Affairs. Discover the report on AER and find out more about our AER members on our website. Our associated open access journal, Ecological Solutions and Evidence, has launched a call for proposals for a new special feature. If you have expertise working on cross-sector or cross-discipline projects or have existing management data you want to share for collaboration, we are welcoming proposals for the rest of July. Please go to the link you see at the bottom of this screen, and we'll also copy that into the chat to find out more. I'll shortly hand over to our speaker for today's workshop, but before I do, please note a few housekeeping rules. The workshop will be recorded and posted online, so please keep your camera and audio off at all times unless asked otherwise. Please send any questions you have or comments via the Zoom chat, and we'll share some of these during and after the workshop. So without any further ado, without waiting any longer, let me introduce Dr. Linda Hirons for her workshop, Co-Production of Weather and Climate Services for Africa. Over to you, Linda.
Hi there. Can you all hear me?
Yes.
Can you hear me clearly, and can you see my screen, Vicky, the slides?
Yes, we can, yeah.
Brilliant, okay. Thank you all for joining. I'd like to welcome you here. My name is Linda Hirons. I work in the National Centre for Atmospheric Science, the NCAS, which is based across a number of different UK universities, and I'm based at the University of Reading. And I'd like to share some experiences with you from co-producing weather and climate services for Africa, and particularly some experiences from recent African SWIFT project. But before we go on to that, I thought I would just do a quick poll. So in the chat, you will see a link to Slido where you can join, and you'll hopefully be able to see there a poll. And I would just like to get an idea of how much people are aware of this concept of co-production. So Vicky, can you now see my poll live? Okay, I can see some people starting to put answers in. Are you able to see that coming in?
We can see the answers coming in, yeah.
Brilliant, thank you. So a bit of a mix. Okay, so you can follow the link in the chat, find Slido. Slido is the platform we're using to have a bit of interaction today, and make sure this isn't just me talking at a computer. Okay, brilliant. I'll leave that going if you want to continue responding, and I'm going to go back to my slides now. So it's just interesting to hear about this concept of co-production, which is probably floated around quite a lot. My background is in tropical meteorology, so I have a background in mathematics and then studied tropical meteorology and the understanding of weather systems in the tropics, and then more recently have been working with researchers, forecasters and practitioners to understand how we take our knowledge of what we know about the climate in the tropics into useful services. And I want to talk about the co-production of weather and climate services within Africa in the context of a recent project that I've been working on called the GCRF African SWIFT project. So I'll take you through some introductory stuff on subseasonal forecasting and co-production, and then talk about the project. Within the project, I'm going to be talking about a subseasonal forecasting testbed that we ran over 2 years, co-producing forecasts with 6 different operational groups across the continent. And I'll particularly pick out 2 case studies within that. So thinking about meningitis, vigilance and early warning for the Sahel, and as well look at a very different sector, look at energy generation planning in Kenya. We'll talk about the lessons learned across this process and some of the future. but I'm going to start with subseasonal forecasting. So having information on subseasonal timescales. So subseasonal, I'm talking about 1 to 4 weeks ahead. It really has the potential to improve preparedness action. So this sits in between our kind of weather information at the one end and climate information at the other. So climate tells us a bit about our long-term climate projections and what's going to happen over the longer term. Weather information might tell us about nowcasting, what's happening in the next minutes, hours, or days, but it's sub-seasonal forecasting, which is really on that extended range, which might give you some information about early warning or proactively mitigating potential disasters. So it's a really key forecast length to be able to give useful information, but it's also a really difficult forecast length to forecast accurately. So it produces a real kind of challenge in both science, but also in co-production as well. So we'll visit some of that. But it has the potential, as I said, if these forecasts can give information that is reliable as well as actionable, then it has real potential to influence and save lives at those timescales. So we'll talk about that a bit more. But you can't create weather and climate services on these timescales without different information from a number of different users. So I want to talk here about the kind of SWIFT project. We had researchers involved, so scientists that have this help us give the nuances on regime dependent skill. This just means which times in the months in the season and which regions have more skill at different times. So how do we understand the forecast? How well is this forecast understood? And when does it have skill? Forecast producers, we're working very closely, as I'll go on to tell you, with local meteorological agencies, and they were able to give us a lot of information about local forecasts and how those conditions manifest locally in terms of what the impacts were likely to be. And then, of course, we were working with a number of forecast users in different sectors to look at the crucial information that might be useful on this timescale to apply into decision making. So I'm just going to take you through the example from weather and climate, and I'll give you an example from seasonal forecasting here because you're probably more aware of this, but take you through some of the questions here that we need to think about. So are there times, so to be able to produce a successful and actionable and reliable service, we need to think about a number of questions, and those questions go across a number of ranges of scale and uncertainty. So we can kind of think about this in terms of science questions that I've got schematically represented here in the yellow, modelling and forecasting questions represented in the green, and then onto the service co-production. So an example from seasonal forecasting. So we know, many of you may have heard of El Nino or ENSO. It's a large-scale driver of variability in the tropics. It manifests in the tropical Pacific Ocean as a change in the sea surface temperature there. And we know that this large-scale driver has influences on local weather in Africa. And we know that it's well represented in forecast models. So are these large-scale drivers influence African weather? Yes, there are. We know ENSO does. Can we skillfully represent those in our models? Yes, we can do a good job of skillfully representing it. And is there a link between this large-scale driver and the local weather? So yes, we do actually know there's a number of studies that have shown how the presence of El Nino or ENSO on the large scale, what influence that has on local weather over Africa. So for example, when you have a very strong El Nino, that's very warm sea surface temperatures across the Pacific Ocean, then you get a very wet East Africa. And this is an example on the right here from a particular season in 1997. So we know it influences local weather, and then are we able to capture that? Can we skillfully represent the local influence on weather? So actually, for this particular example, forecast skill of rainfall in the long rains has been shown to be much higher, so out to 4 weeks during. So when you have a very strong El Nino event, the forecasts are likely to be much more skillful because we know the large scale conditions and we know what's happening. So the answer is yes in that sense. And are we able to turn that into an added predictability into the reliable and actionable forecast for users? So this is an example from work that I did with then DFID, the Department for International Development, looking at country partners across East Africa and trying to understand the likely impacts that this developing El Nino in 2015-16 would have on temperature and rainfall across the region and across different countries, and which sectors that is likely to impact in what way. So this is an example of where a large-scale driver that we understand and can model has local responses, so manifests locally in terms of how it affects hazardous weather in Africa. We understand what that does to the skill of the forecast, and we can turn that into some useful information for people to use in their context. But it's becoming increasingly clear in this that to co-produce new services with users is key in maximising this potential. So you can't do the yellow and the green boxes here in isolation from the blue, from the users and how that information is being used and applied in decision making. Equally, you can't apply information in decision making. You can't apply this blue box blindly without understanding whether your forecast has skill, and if we understand why the forecast has skill at particular times in the season. So this is helpful to think about how we go across these questions within the weather and climate sense. But I'm aware that you're not a group of weather and climate experts, so I'd like you just to consider now what are the important questions to consider within your ecological context. So if you go again to Slido, I've posed that question for you. We can have a bit of time here to think about it. But this is basically trying to think about what are those important questions. What would you see as being important? From my weather and climate context, I've said we need to know whether there's large-scale drivers, whether we can skillfully represent them, whether we understand the links between the large-scale drivers and the local weather, and whether they have skill, and how that links to co-producing effective climate services. So I'll leave that open if you want to continue to think about the questions there as we go through. It might also be helpful to think about this when we're considering co-production within your ecological context or within your area. It might be that there are particular groups of stakeholders or actors who aren't currently sufficiently involved in the production of ecological services along the whole value chain. It might be that you have a lot of information at the start of that. You might have a lot of the scientific background, but you don't have a lot of the context from the forecast users or from the users of that information about how it's going to be applied in decision making, or what aspects are going to be important there. So it might be that there are whole groups of actors that aren't currently sufficiently included. So thank you to those who are starting to add questions there. I'm going to leave that open because I can see others are contributing. So I think these will be really interesting to come back to as we continue through. So thanks to those who are adding information there. And I think these are some of the important questions if we want to learn lessons that can be applied in your context. So that's kind of an introduction to the sub-seasonal side and the forecasting and co-production. I'm going to now introduce to you the SWIFT project, because this is the context that we've been using to apply this information. And I want to go through that in a bit more detail. So African SWIFT, it's GCRF funded, so the Global Challenges Research Fund. And the SWIFT stands for Science for Weather Information and Forecasting Techniques, which ran from 2017 and recently finished in 2022. And you can go here to the website and have a look at the legacy site, where we've got a number of impact case studies, a number of policy briefs and publications and resources from the project. But the project's overarching goal was to deliver a step change in African weather and forecasting capability from hourly to seasonal timescales, and to build research capability to continue those forecast improvements. So some really big aims. Within that, I was leading one of the work packages, which was looking at a particular timescale. So this sub-seasonal timescale that I've mentioned before of 1, 2, 3, 4 weeks ahead, not looking at seasons, but looking at the weekly forecast. Is there information? Are there drivers of predictability on these timescales that we can understand? Do they have skill? And are we able to build research and forecasting capability within Africa to support that potential? And cross-cutting here was a sub-seasonal forecasting testbed. So that's what I'm going to be talking about here. And that's where we were using a co-production approach to bring together different knowledge sources, experiences, and working practice to jointly develop new knowledge for addressing societal problems of shared concern. So for those of you who answered in the initial poll, I've no idea what you're talking about. Co-production can be defined in many different ways, but it's the bringing together of different knowledge sources to jointly address problems of shared concern. So within a weather context, within a forecasting context, this really transforms the role of the user away from just being a recipient of the information to being a participant in the knowledge generation process. And it shifts the emphasis from a supply-driven forecast to a demand-led process. And I can see that people are continuing to add questions, so that's brilliant. Thank you. I will return to that shortly. But this might be, for example, I'll take you through the case studies, but it might be that a particular user has a different threshold of what an extreme looks like, or a different idea of how you might visualize a forecast to be more useful to their users, or a different idea of which variables combined actually are influential for their particular decision-making context. So there's lots of ways that co-production can affect that. And we ran a forecasting testbed. So a testbed is a forum where prototype forecasts are co-produced and operationally trialed in real time. So African SWIFT was granted 2 years and then extended because of COVID to 3, but we had access to the sub-seasonal forecast models. So this is part of the S2S prediction project run by the WMO, the World Meteorological Organization, and they granted a number of products real-time access to this data to see if it could be used to benefit societies. So SWIFT was one of those projects. There were 16 in total. I won't go into the detail of the climate and weather data because we don't need to worry about that too much here. But we used, these are state-of-the-art models which weren't usually accessible in real time. So the difference here was that we were able to have these forecasts of the state-of-the-art models like ECMWF, which is the European Centre for Medium Range Weather Forecasting. We were able to have those in real time to have this 2-year trial of whether this was useful. And we were trialing this across 6 different operational groups. So these were 4 SWIFT partner countries of Kenya, Nigeria, Ghana, and Senegal. And then we had one regional climate centre in East Africa, ICPAC, and a Pan-African organisation, African Centre for Meteorological Applications for Development, ACMAD, which is based in Niger. So a Pan-African organisation as well. And each of these, what was nice here was that in country, each of these national Met services from these 4 different countries was supported by an in-country research institution, university, to build this collaboration between the national Met service, the forecast application, the forecast provider, and the research institute, and the researchers. And each of our operational groups worked with a particular, they identified a particular user within their working environment that had a need for information on these subseasonal timescales, so 2, 3, 4 weeks ahead. So we specifically targeted a small number of users to try and make sure that we could build this trial effectively. And we worked with sectors like agriculture, energy, health, food security, disaster risk reduction. So each of these 6 operational groups was working in their context with different users. And the approach we used here was building on previous work. So I've got up here a copy of the manual, the co-production in African Weather and Climate Services, which was a manual that was produced through the WISER and FCFA, Future Climates for Africa projects, which I was involved with as well. But this was basically a manual that set out some of the examples and the things that have been learned and gave good guidance for good co-production. So we were using this as our guide and used the 6 building blocks of co-production here on the left, and you can see the 10 principles identified as underpinning effective co-production here on the right. So I won't go through these in a lot of detail, but can provide access to this manual if required. But we identify key actors and build partnerships. So this is part of the reason why in our 6 operational groups we had really close interaction with our users from the start. And you build common ground. That means you come together and you have to get an idea of what the problem is, consider competing priorities, managing expectations, and what might be the challenges that might occur there. And part of that is also this co-exploring needs. So understanding between the partners and creating a space where the jointly defined issues can emerge. So it's no good one partner coming in and saying, this is the problem, we need to solve this, and the other partner saying, well, that actually isn't our problem is this. So it's a really useful space to come together and explore what the actual issue is and where the challenges are. And from our weather and climate context, it might be that a user says, I need to know how much rain there's going to be in 2 weeks' time at this exact location. And a forecaster will say, well, our model can't produce that, but I could tell you how much rain there's likely to be across that week in that region. And this is how much confidence I have in that. Is that any good? And then the user can say, well, are you able to give me, what if I look at that in a location, how much skill has that got? So it really is an iterative conversation about what's required and what's possible. And that's part of co-developing and delivering these solutions. So, looking at the forecast, assessing its skill, evaluating it as we go through here, and iteratively going through these steps again and again to understand whether that new forecast product has skill. Does it inform a decision? Is it helpful? Is it useful? Is it actionable? Does it help the need it was intended for? How could it be improved? And this is a really interesting iterative process as you go through. And we started with a workshop which brought together a number of attendees in Kenya in 2019. So we had users from agriculture, from food security, energy, disaster risk management, as I mentioned, operational forecasters from partner countries, researchers from 7 different African countries, and from the UK as well. And we went through some of these initial building blocks and thinking about what information could potentially be useful, what expectations were we bringing to the testbed, what themes were common among the sectors. So thinking now cross-regional, but common sectors, were there common themes coming out? And we looked at our timelines for decision making. So when in the year are particular decisions made, and when is information required? And then also looked at the country level network mapping. So this was exploring the local governance structures into which this new information was being added. Is it added into existing pathways of knowledge, or are we creating new pathways? How does it coexist with what is already in there and what information is already existing? These are just some pictures here from the kickoff. We had all of our different operational groups coming together and brainstorming on timelines of decision-making, country level network maps, and a lot of really good outputs. I'll give you a reference to the paper that describes some of this in more detail. But of course, that last building block number 6 was about evaluating, and you can't give forecast information unless you are confident that the information that you're giving has skills. So we did a really comprehensive assessment of the forecast skill for weeks 1, 2, 3, and 4. And I would encourage you to go away and read this paper if you're interested in more detail. But this plot on the right looks at the different drivers of potential skills. So I talked about ENSO, El Nino in that first example, but we've also got included here things like the Indian Ocean dipole and the Madden-Julian oscillation, which are large-scale drivers of variability in the tropics, which we know influence local rainfall. So this comes back to those boxes before, the yellow boxes. Yes, we know there's large-scale drivers. Are we able to represent them in models, and can we represent their local impact? So some really interesting questions coming out from the verification side. And importantly, if we're creating new forecast products, what sort of level of skill do they have? Are they effective? And is it effective? You can see on the left here, the skill from week 1, 2, 3, and 4 obviously declines through the forecast. So as you get a longer forecast, your skill is less, but there's some regions and some seasons where you still get considerable skill even out to 4 weeks ahead. but not all regions and not all seasons, which again is a nuanced part of the challenge to communicate. To take you through some of what the groups did, we don't have time to go into all of this, but we had weekly precipitation anomalies, soil moisture anomalies. Some groups looked at surface relative humidity in Nigeria, for example, where they wanted to know a lot about the harmattan and the dust. What were the dust conditions likely to be? Looking at extremes, so user-defined thresholds for what an extreme is and what are the probabilities of reaching those extremes. Country-specific things, looking at large-scale drivers like the MJO, thinking about soil moisture in Ghana and Nigeria, and then applications in health. I'm going to go on to that in the case study, like the meningitis bulletins, urban flood risk for Kenya. This was a really interesting link with another project called 4PAC. So loads of really interesting applications of these forecast products iteratively produced based on user-defined changes and inputs. So just to take you briefly through two case studies. So one of them is this meningitis vigilance for the Sahel. And here ACMAD were working really closely with the WHO, the World Health Organization, to supply bespoke multivariable products for meningitis vigilance. And just to give you the context here, we know that meningitis occurs sort of 1 or 2 weeks after a big dust event. And we also know the environmental conditions likely to cause one of those big dust events. So here we were combining forecasts of temperature, relative humidity, wind speed and direction, and dust forecasts as well to predict where these meningitis outbreaks were likely to occur. And thresholds were applied and given based on those, based on the World Health Organization knowledge and forecasting knowledge here. And we added forecast data. So previous to SWIFT, meningitis vigilance maps were being, these sorts of maps were being given out, but not with any forecast information. So only based on what is happening now, can we tell you what's likely, where meningitis is likely to occur. So adding the forecast increased the lead time by up to 2 weeks, which had a huge implication for improving the preparedness of action and where measures could be taken to save lives. And it still requires further work and further evaluation, but Sheikh Dion, my colleague here, has recently had the paper about this accepted in climate services. So there's some really interesting initial work here that could be extended, but having trust and in reliable forecasts, you can add 2 weeks to your early warning for meningitis across the Sahel. So that's a really powerful output. Another example is from the energy sector. So energy generation planning in Kenya, we worked very closely with KenGen, which is a large energy company in Kenya. And they were involved from the start of the testbed, came to the kickoff and were involved in the co-production process, the building common ground and co-exploring the need during that workshop. So their forecasts were used for hydropower generation planning. So in Kenya, hydropower accounts for about 45% of the total energy across Kenya. And these forecasts were being used to help manage the dam levels, to ensure that the dams could be sufficiently full to provide enough water for the dry season, but not too full that they would overflow and cause flooding downstream. So using these longer range forecasts to understand how to manage those dam levels to maximize the impact. And this is a quote from Willis here. This had some real impacts for Kenya from an energy context. So they were able to have uninterrupted power during the running of the testbed. So usually there's a lot of intermittent power and loss from the grid because of unreliable sources and a lot of unpredictable sources. But we were able to add some information to hydropower planning, which meant uninterrupted power and eliminated the need of these expensive and unclean diesel generators. So some really tangible impacts of what having more effective weather and climate services on these timescales can do for people. And there was a lot of lessons that we learned in this process, because for many of us, we were working in a new way, way of producing and collaboratively generating knowledge. So one of the things here is that to ensure that there's sufficient resource to support the co-production process. it's really resource intensive to work in this way, to iteratively go through and have a conversation about what's useful and what could be applied and how it has worked and whether it's got skill. And it takes a lot of time, and it's time that isn't necessarily already factored into people's workloads. So a lot of challenge in terms of resource. And the efficacy and resource demands of different co-production approaches, it still requires more thorough assessment and metrics for measuring their effectiveness. And I think this is important because we could still do a lot more about the user evaluation. So how are those forecasts used, and can we qualitatively or quantitatively think about how those benefited people within the whole value chain? So a lot of interesting things to think about. We need to support capacity building of all the stakeholder groups. So it was a new way of working for many, and it required a new set of skills. So there was a need to strengthen decision makers' understanding of key forecast concepts, but also enhancing the producers' and researchers' ability to effectively communicate technical concepts and understanding the decision-making context which they were producing forecasts for. So there was a lot of interesting conversations at the start about how are you going to help me make a better forecast, or how is your forecast going to support my decision if I don't trust it? So a lot of interesting conversations here. And this last one, including decision makers in the forecast evaluation, we can do a really systematic verification, as I've mentioned, that we did do, about how these products when and where they're skillful, and that's helpful and useful and important information to be able to communicate. But we also need to know whether it's actually supporting a decision, whether it's actually effective in the context it's been designed for. And it's key that this is iterative, as I mentioned. And there's a paper here that you can go away and read and have a look at, which has a lot of contributions from partners across all of those different operational groups. There's also a number of other peer-reviewed and non-peer-reviewed outputs that you can have access to and read about, policy briefs and newsletters in the ECMWF and WMO State of Climate Services report. So a lot of interesting outputs here that can give you some more information. And just coming back to co-production now, one of the key here is it shifts the emphasis away from a supply-driven forecast product to a demand-led process, which is really key if you're going to actually influence and help people. And another part here, which is probably slightly lost in nuance, but it's the direct access to the raw data, which really enabled all of this to happen. So having direct access to the data, and I mean that in the sense of rather than having access to a number of pre-produced forecast products that you can look at online, having access to the data meant that you could change the forecast products in a way that suited your user. So user-directed iterations could influence exactly how you produced your forecast in terms of which variables you use. So in the meningitis case study, you could combine variables together for a particular application that you knew needed that combination. You could manipulate your data to provide more user-relevant products. So in the example of the extremes, you could apply user-relevant extreme thresholds. And then around visualization as well. So you could change how the forecast data was presented to make sure the information was clear and correctly interpreted. So all of these things could happen because we had direct access to the data rather than just access to outputs and forecasts. Products. And we've been thinking a bit more within the project. I'll finish shortly, but we've been thinking a bit more in the project about how we can think about pathways to institutionalize co-production of services. And there's a co-production policy brief coming out as part of the SWIFT project, which looks at systems, relationships, capabilities, and how we can think about making this the norm for the future. So I'm not going to go into that in too much detail now, but can do if you need to. So again, return to the website if you want to see a bit more. And of course, I didn't do this all. It was a huge team who got involved from all of the different partner countries and regions. So it only happened because everybody was involved. And I'm now going to return to our Slido and then take questions from you. But first, we're going to do a word cloud. So thank you for everybody who's been adding questions here. We can come back to those in the Q&A if we want to, but I'm now going to just set this going. So what does the co-production of new services really mean? So feel free to add a word, a number of a sentence here, and then after this, I'll take some questions. I'm adding my own. So Vicky, I'll pass back to you and you can take questions when you feel.
Thanks so much, Linda. So I can see there's still some more answers coming in, so we'll just give people another minute or two. I've just reshared the link in the chat for anyone that has joined us since we first started. So to get to Slido and give your answers, please follow the link in the chat. We'll just give you another minute or so to add to the word cloud. Okay, keep adding, everyone. While you do that, maybe we can open for some questions. So I can see we've got a number of questions in the chat, Linda. First of all, thank you very much for a great talk. So first question is coming from Emily. So she asks, can these co-production approaches work on different, for example, longer timescales as well? Or do you see them as most useful at very near term?
Thanks, Emily, good question. I'm going to leave this word cloud going, if that's all right. Good question. I think they can be used on any timescale, and provided the key here to me is that you set aside enough time and resource for the start of that co-production process, which is the identifying key partnerships, building common ground and co-exploring the need. Provided you set enough time and resource to do that effectively, you can collaboratively design, or you can collaboratively shape the problem that you're trying to address, and that could be on any timescale. So for example, within SWIFT, I didn't go into it here, but within SWIFT we also had a nowcasting testbed. So this is looking at forecasts completely at the other end of the spectrum. So what's going to happen in the next hour, 2 hours, and we took a co-production approach to that as well, and thought about how users might improve the effectiveness of those sorts of outputs. And then going back to the manual, the FCFA forecast future climate for Africa. So the manual there was based on a project whose timescale was 5 to 40 years. So thinking about not just what's happening over the next few weeks, but what is likely to happen in a future climate, in the near-term future climate. So I think it works on any timescale, provided you give enough resource to those first building blocks.
Thanks, Linda. Great. Another question then from Jeanette. Who were the key users and how did this affect the media through which the data was made available?
That's another really good question. So I think this is a complex question to answer. So within the testbed, in the user sense, we were probably working with quite technically savvy users. So if I take the meningitis example, so we're working with Dr. Bouaka, who's who's very established in the World Health Organization, so based in Burkina. So so I guess the individual users that we worked with on the testbed are quite technical, high level, but we were thinking the idea of the network mapping was thinking about the cascade of information. So how does that link between what's coming from the forecast and what's happening further down that cascade of information? How does that look in different contexts, different sectors and different countries? So in some regions, for example, in Ghana, they developed a really effective SMS alert where they could send out their information by SMS, by text to all mobiles. In Kenya, as part of the nowcasting stuff, they actually developed a really effective app, which is now available to download and look at to tell you where the storms are likely to occur. So it depends a lot on the context, but generally we had that whole networking exercise was looking at how the information would cascade from where it's being created and co-designed to where it's being used by somebody you might term an end user.
Great, thanks, Linda. And a follow-up question then to that from Peter is, what's the name of the app that you mentioned in Kenya?
It's the Faster app. Let me find.
That's FASTA, isn't it?
It is, yeah. I'm just wondering whether that's, where's the quickest way to find the exact. I'll get it to you and put it in the chat. Okay,
great. Brilliant. Whilst you're doing that, anyone that's got any more questions, do put them in the chat. We've got a couple more if you're okay with those, Linda.
Yeah, go ahead.
You can multitask. So Amasali asks, how easy or difficult is it to replicate those co-production for other countries?
Good question. So a lot of what we covered in the policy brief was trying to think about what were the benefits and challenges of co-production in this context, and how could that be scaled to other countries and regions, which is a really important idea. I guess some of this would come under capacity building. So if you brought those other countries and regions into existing workshops and to share some of the lessons that you've learned and to talk about how that worked in a particular context, you could try and find partner organizations in those countries. So the energy example, so we're doing this already with the energy example. So working with the energy sector in Kenya, we're working with power companies and also the Ministry of Energy, but now thinking about how we parallel that with the National Met Service in Tanzania, for example, and the energy ministry, the energy users in Tanzania. So if you can think about doing that by looking at similar sectors in a neighboring region, or you can think about this in a more broader sense. So one of the things we tried to do was produce things that are called SOPs, so standard operational procedures. So these were templates for what we did and detailed information for what was required to co-produce that particular forecast product, and having a catalogue of those so that they could be freely available for other people to use and look at in terms of what was needed in resource, in time, in expertise to be able to do this, and is that something that we could reproduce somewhere else? So having those standard operational procedure templates is really helpful.
Brilliant, thank you. Okay, question from Kevin. How do you integrate issues related to gender, age, cultures and traditions, different land users and livelihood streams in co-production of forecasts?
Great question. And I don't claim that we were targeted in this sense within SWIFT, but I think it's a really important question. So as I alluded to earlier, we were working with quite technical users, which already excludes non-technical or less literate localized users or end users. So I think it's a really important, and as you mentioned, marginalized groups as well. So I think the way that I would do this, and currently learning so many lessons and redesigning new projects, is that you would have people with those expertise involved in the process from the start. So that requires working alongside social scientists who are considering the process. Are groups equally represented? Are voices, even within those groups, being equally heard? And how does that information filter through and cascade down the communication timeline? And are there links that are being missed? So I think it requires really working interdisciplinary with social scientists to understand the process and the outputs, as well as developing those. So I think it's a great question, and I think it's an area which we could do a lot more work in.
Great. And then one from Henry. I think this is a very valid question. Co-production seems to work best through initial in-person meetings. What was your experience of co-production during the pandemic? And do you have advice for trying to develop co-production projects when in-person meetings are likely to be rare?
Great question. And I think you're right. So we managed to sneak our kickoff workshop in 2019, just before the pandemic hit. And we had plans for all sorts of other workshops, which would have been brilliant, that couldn't happen. And for example, we had what we called a hackathon, which is where we brought some of our East African colleagues over to the UK to spend a week looking at the data and trying to understand what questions the data could answer. And we had plans to do that with our West African colleagues as well, but then the pandemic hit. So it was really hard, is the short answer. I think there's ways to do it. And because we were working across so many different operational groups, we were already doing a lot of hybrid meetings anyway. And I think that has worked, but you're right that an in-person collaboration helped build those initial relationships. So I think regular meeting, I think ensuring that hybrid meetings are well chaired, so that there's space and time to ensure that different voices are heard. Regularly checking in to check if there's accessibility issues or timing challenges, ensuring that timings of meetings work for all partners, ensuring that if you're trying to meet with users, that they have the technical capabilities to join the meeting that you're requiring them to join. So there's a lot of challenges, and in many cases WhatsApp was a really good way to communicate because most people had a phone. So I think being agile and flexible in the way that you do it is really important, but I think it's a really important question and something that we're all going to need to consider as we go forward.
Okay, great. Thank you so much, Linda. That is all the questions we've got, actually. But thank you, everyone, for your questions. They were quite thoughtful. So that's great to hear some of your ideas as well. And thank you, Linda, for your talk and for answering your questions. There's a number of links in the chat to various bits and pieces. So if anyone is interested in following up on anything that Linda's mentioned, have a look at those links. That might be of use to you.
I'm just about to add the... I'm finding it. I got distracted. I'll add the faster link for the app.
Brilliant. Okay, so keep an eye on the chat if there's anything else you're interested in. Okay, right. So with that, thank you everyone for coming to today's session. That brings today's AER Live to a close. Thanks massively to Linda and everyone who joined us for today's workshop. Before you go, we'd like to announce that registration for this year's British Ecological Society annual meeting is now open. This is Europe's largest ecology conference, and it will be held this year in Edinburgh. You can register now both for in-person and virtual content. You can see the link on the page here, and we'll also copy that into the chat. And finally, if you've got any questions about applied ecology resources or have any suggestions for future AER Live workshops, please get in touch at hello@appliedecologyresources.org. Thanks again for everyone for joining us today, and hopefully we'll see you all again at a future AER Live event. Thanks again to Linda, and take care everyone. Bye.